Hello everybody. This is another support material for, because I was asked in the last session to go over some of the examples from this book. Probably like this is the only book that is about like 3D printing with ceramics, like clay, for example, like FDM, which is a very nice and explicative book, but there are parts that are hard to follow if you're a noob, basically a newbie in a Grasshopper or parametric design, or you don't have much experience. You have experience probably in Rhino, but not so much in Grasshopper, so you don't understand things related to like data list management and so on and so forth. So what we will do today, and this is it's formalized because I checked this, or I went over this exercise with some of you in the last session. I'm preparing this material to go over the example of the cover, or like the back cover, right? This one, which is in the page 100 and let me check, 120. It's this example here, and how to create basically like printing paths or sections based on isocurves. So this is a very nice example. The only problem is that kind of confusing because having the possibility of parameterizing everything, including the curves in that book, the example only shows you how to create basically like the curves on first on Rhino, and then do it or basically parameterize all the creation of the line. So we will go over the full example, creating the curves, and I will do it probably. I mean, if you're watching this video and you already know how to do this, you probably will say like this is like very inefficient what I'm doing. But this is a video for, it will be published on my channel, but this is a video for my students that they don't have any previous experience in Grasshopper, so I have to make it like longer, right? I will try to avoid as many tricks as possible, and probably I will repeat code, and probably there are ways to make it more efficient, right? This is not the purpose. This has like a very like clear pedagogical purpose. So let's get into it. All right, so we will start our file. I mean, you can, if you have the book, you can of course make it start basically like replicating what's in the book in terms of the curves, and then the definition. We will basically follow that. I mean, I will not show the book or the exercise, but I will guide you step by step explaining what's going on. So the first thing that we will do, actually, because we don't want to generate anything, we want to have like a independent definition, Grasshopper definition. We won't do any scripting. We will create a Grasshopper definition, and we won't create any Rhino geometry, right? So we won't be using this like geometry container or instance containers, right? So we will start by double-clicking, writing circle, and we will create a circle that has by default values like the plane and the X and Y, basically X and Y plane, that has the origin in the geometric origin of our modeling space, right? And we will specify a radius. So yeah, the radius of the exercise in the book is 10 centimeters. Whatever. We will generate a slider that goes from, I don't know, 0 to 10, and then we can play with the values. So let's say, yeah, this is 10. So we are creating this. Just let me the plane size, I'm gonna set it to 3 maybe. So our planes don't look that big. And let's check the units in Rhino. So work in millimeters. We're gonna work first with centimeters. Actually, let's work in millimeters, because if you're going to 3D print this in clay, it's good to have this that way. So we will say that our circle is 10 centimeters, and here what we want to do is to basically start creating the curves, the parametric curves that the book in the example is showing. So if I go quickly to page, basically, like, we will parameterize what exactly is not parameterized or produced in Grasshopper, that are these curves. So we will start by moving. We will move this curve a certain amount of units, right? So we will move this vertically. So to move this vertically, we just double click and create a vector in the vertical direction, right? And then we will specify an amount, basically a length of that vector, to make the translation. And in this case, we will say, let's set it to 10,000, so we can move it or whatever. So we can move this, I don't know, 5 centimeters. And what we do, we have our geometry that, remember, if we select the geometry, it turns green, and we will connect it to the move component. So you see now we can basically play parametrically, right? Actually, yeah, that's 5 centimeters actually. Let's make this like, I don't know, 2 centimeters. So this is our first curve, and we will work with this. So what we want to do is to modify this curve, right, or to create another curve. And we will follow the logic of the book, that they tell you, like, do everything and how to do it in Rhino, right, step by step. So and that is very cool, because it has a very, like, fabrication logic. It's like fabrication oriented. It's like design for manufacturing, not just for modeling. So we will do the same. We will rebuild our curve. We'll rebuild this curve. And we need to specify a couple of things. So for example, the degree of curvature. We will say that our degree is 3. Remember that there are, like, many numbers of curvature. If we rebuild this as a curve with degree 1, basically what happens, let me turn off the previsualization of the original translated curve, it turns into a polyline because there is no curvature. Then if you do 2, basically it's a circle again, because it creates the curvature based on arcs, and this is like a proper nerve curve. So we will leave it like that. We will create another slider, and the slider will be or will indicate am I using the good, right, this was not the, let me go to curve, curve, should be around here, the rebuild. No, util, sorry. Rebuild. This is the one. Yeah, I was using another component. I don't know why. So we will rebuild the geometry as a degree 3 with 10 control points. So the count is the number of control points that we want to have, right? So we will do this. We can say that this is curvature degree. This is n control points. Perfect. This is like height, and this is circle radius or base radius, whatever you want to call it, right? It's good to basically name what you're doing. So that will be the next operation. And based on this, we will create another control polygon. Basically, we will go here and we can extract, actually, sorry, the points. So we can go here, curve, control polygon. And what this will do, basically, it will extract, or it will show you all the points, right? Or you can do control points as well, right? But our control points are the same. So this is the control polygon. Let's use control polygon. It's fine. And now what we need to do is to we need to create a selection. So this was like the tricky part, right? That I show to some of you, but I want to everybody like now understand what we did. We will go to sets. We will go to, in this case, partition list, because we want to group. Right, just let me do a quick bake. So what we want to do is to select or to group every other point. And actually this is not 10. This is, now I remember, this is 16. Let's set it to 16. So we will maximum number 50 and the value will be 16. Yeah, so let me delete that. Let me bake it again. So we want to basically work with this logic. Select every other 2 points, right? Because then we will make this. We will scale these points to deform our curve and to create something different. So let's do that. We will take the points. So remember, if we add a panel here using /, we will see that we have a list with all of our points. So we want to create new list with 2 points each. So we will say here our constant will be 2. So we can create a panel because this will be a constant. I like that this is a panel, so we don't modify that, and you don't basically like modify something if you forget your name. To put a name, then you can create something that is not. Basically, you can make a mistake and then you won't remember if you change something. So now look at what happens if I copy and paste this. You see, now we partitioned this list into 2 elements, right? Like list of 2 elements, and it doesn't matter because it will leave one here, so we can deal with that actually. Actually, we need to do this 15. So we'll have, yeah, we have our list with the even or the equal amount of data. So now that we have this, what we want to do a cull pattern. So basically we want to create 2 patterns of selection of the things that we're doing. So if we go to set, we go to sequence, cull pattern, and what we want to do is to create with another panel. We want to say true, true, false, false. And after the last false, remember, I'm not pressing enter. I'm just like clicking outside. Then I right click on the panel and I said multi-line data. If you press enter and then click outside, you will get an error because this is creating another element that is empty. So remember that we saw that with your classmates. So we want this. We will use this a lot. So actually this is a good exercise to understand that. So we will add this cull pattern. This is applying a mask to our data. And if we select this, we will see that the output in this case are the output is basically oh, and we need to flatten this list, sorry. So now we have only 8 elements. So if I select this, you see that we're getting the selection that we want. We have this point selected, these are not selected, these are selected, these are not selected, and so on and so forth. Because we are applying this is like a filter. It's saying like, take the list, a flattened list, right? Where basically it's just like one list with actually we could have done this and it's the same. It doesn't matter. Actually, yeah, we don't need this partition list now that I realize we did it for another purpose. So if we do this, basically we are filtering our points, and we can do the opposite, right? So here we have 8, and now we will also want to have the opposite selection. So let's just copy this. Yeah, sorry about this because I'm checking the notes of what we did in the session. It's not necessary unless we want to get the data structure. Maybe we will utilize this later. So here we just we will reverse the pattern. So we will say false, false, true, true. So this will generate the inverse selection, you see. That is very nice. So once we have this, we can do a couple of things. So basically we want to deform this curve. We want to move half of the points. So this selection here, we want to move it like some units in the C positive direction and the other ones in the negative direction. So let's say we will move this in the positive direction. So we will apply the same move. We will move this geometry, we will move it vertically. So this is why we need to create a unit C. Remember, double click C, and this is the unit C. This is a unit vector, right? We'll put it here, and we can specify with the slider the amount of units. So let's do something that goes from 0 to 1. From 0 to 100, and let's move this. I don't know, like 15 millimeters. So you see, we're moving this only these points 15 millimeters up. So we can actually turn the visualization off. We can also turn this visualization off. We don't need that. So you see that now we have some points that are up, the other ones are down. And we want to do the same thing to the other set of points. But in this case, as I told you in the last session, we can just copy this, use the same sliders, the same unit C vector, just change the geometry. But before connecting the actual vector, we can reverse. So if we double click and write reverse, we can, as the name is pointing out, reverse the vector. So now we have the possibility of just like changing. So let me also preview this off. And with the same slider, right, just manage how much some points goes up and the other ones go down. So that is pretty neat. We will leave this to 1 centimeter. And now that we have this, what we can do, we can build a curve, right? So again, we're taking a long path to teach you how all of these elements work, and we want to create a curve. We will create a let's create an interpolated curve. Interpolate. Let's try that. Let's go to curve. Polyline. Sorry. Interpolated curve. So here it's like, how do we basically enter the right data, right? So if I connect this here and then I connect this here, pressing left shift. So if I press left shift, I can do this, and this is doing something that I don't want, right? Because this is creating a curve that is starting from the first set of points that are all down, then it goes up, and then it finishes. It's not what I want. We need to give the data in the right order. So in order to do that, we will use the width component. So basically, we will take a couple of elements, like some elements from the first list, assuming that this is the first set of points and the second set of points. So to do that, and actually also let me lose the pre-visualization of that. So we need only the base curve and the new set of points, and we will use the weave component. Weave. So the way it works with a pattern. In this case, we're just feeding two streams of data. We will say that this is stream 0 and this is stream 1, and we need to give a pattern on how this thing is going to happen. So by default, it has 0 and 1. But what we want to do, because this will be what we want to do is to pick two elements from this set of points here, then pick the next two from this set here, right? Because imagine if I connect this will create also something undesired. That it kind of looks like interesting, but it's not what we want. So basically we want to pick like two that are in the upper side, let's say, these two, then the other ones that are below, and so on and so forth. So we need to modify that pattern. And we do it in a similar way as we did it for the calling pattern. So we say like 0, 0, 1, 1, and click outside. Right click, multi-line data. So if we do this, we get what we want. So basically saying like, use this pattern. Start with 0, meaning that you will get the first element will be from the stream 0, second element from the same stream 0, then the third element will be from stream 1, and the fourth element will be from stream 1. Remember that these are all 0-based lists. This is why it goes from 0 to 3, and I'm saying like first element, second element, and third element, even though the index of the element is 2. So once we have this, we can just add a toggle. So if we go here, actually let me show you, to input, we can add a toggle value that right now is false, and we will put it to, or we will connect this to periodic. And basically a periodic curve is a closed curve. So if we just say like close, it closes it, but it gives us an undesired effect. So let me check why this is the case. Actually, we need to add 16 points. Yeah, we need to add this to 16, so we have the curve the right way. So remember to modify this to count to 16. So now we have our curve. This is the first curve, and it's exactly what they asked. Again, let me check the book. So basically it's one of those curves over there, right? So that is super nice. Now what we need to do is to create the second curve that follows a similar workflow. So actually we can copy everything, but we can perform, it's basically the second curve that we need to produce. I'm just gonna make it like really fast here. Rebuild, we'll rebuild this with 16 points. Actually this was 10 if I remember correctly. No, it was 16 as well. It's like this. So it was again selecting like every other 2 points, and then it performs a scaling operation. So you can create a figure like this. So you can create like this type of shape or this type of shape. Very interesting, but again, we don't want to model it because we want to explore, basically like explore the design space based on this parameter, right? Just playing with the scaling of the points. So we will do that. Remove this. So just to make like everything like easier for us, we will put this here, and we will copy everything until let me see, until let's just copy. Actually, let me just, I will move this above because probably we will need it later. We don't want to, we're moving this. So just let me, this here. Yeah, we will copy all of this, all these elements, like moving, rebuilding the curve, the control points, the code pattern. We'll copy and paste. So again, using the same slider, we are just copying until the point where we are basically filtering, or we're having two set of points, like the opposite set of points. So I will preview this on. So remember, we had this original set of points and we have select every other point. So the difference here is we are not going to, we will not move anything in the vertical direction. We will just scale in a specific set of points, right? So we will do this with this first set of points. We will add a component that is scale. A scale, you can find it in transform, it's an affine transformation, right? And we will grab this specific set of points. So look what happened now that I connected the set of points, this set of points to scale. Basically, it scaled everything according to the values that are predefined. It's assuming that the center for scaling is the 0, 0, 0. So this is something that probably is not what we want, because we need to specify a specific center for the scaling operation, because the points are not only scaling, but they're moving down because they are being scaled according to this origin point. We will check that. And originally the factor is 50%. So basically it's scaling those points 50% to the half. So there are easy ways to do this. I think like the easiest way will be just go to, for example, we can say, yeah, we can double click and write area. So we have M2. So basically solve area properties for B-rep meshes and planar curves. But also it works really well, for example, if we feed, for example, like all the points. Sorry, if we feed, in this case, like the curve, the original curve that we just rebuilt. So we will get the centroid, but the centroid basically is a line. It's at the same height of the points that we're using right now. So we will use that centroid to perform the scaling operation. So you see now the points are coplanar with the original ones, like these points are coplanar with these ones. And we need to specify the scaling factor. And this will be one parameter to play with, right? So we will say that our this is a little bit exaggerated. So let me do maybe a slider that goes from 0 to 5. Actually, yeah, 0 to 5. Factor. So you see 5 being like very big. We don't want to use that, but we can do, yeah, some operations. So let's just preview that. Also, I want to turn off the preview for this, so we get like a clean visualization of what we're doing. Let's preview off that. So now we will perform a similar operation than here. So now we need to basically specify, we have two set of points. We want to rebuild a curve. So let's just copy these elements from the first curve that we produce here. And let's copy this down. So now we have again two streams or set of points. our stream 0 will be the scale geometry, and this is actually quite interesting, the curve that we're forming here, but we're not going to use that, and we will input the second set of points. So let's just turn off those points. What we have, it's another curve. So here curve height, and this will be how can we call it, like center scale, I don't know, you put the name. But you see now that we can control this curve, like let's say like on the plane, horizontally. Quite interesting, because this will be a profile for our lofting operation, and the other one is a curve that is controlled in that way. Very nice. So now that we have these two set of curves, let me just align this. What we can do is to let me think a little bit. Yeah, what we want to do actually is to repeat this and maybe play with the code pattern to basically like play, because basically now we want to do a couple of like operations that had to do with mirroring and culling some of the elements. So we will work first. Where's my mouse? I'm always losing my mouse. Oh, here it is. We want to play a little bit. Let's work with this first set of curves. Actually, let's repeat both set of curves a certain amount. So in this case, what we want to do, we want to create a series of numbers to create the repetitions. So by default, it goes from, if I put my mouse on the start, it's 0. It gives you 10 steps. Sorry, 1 step. We will change that according to a height of these curves and a certain count, a certain amount. So we will create a couple of sliders here. Let's say 100. And let's set this to, I don't know, 15. That will be our step. We will repeat these curves every 15. Actually, it should be more than this here, so we don't have like let's set this to 20 actually. Let's say the number of curves for now, we will say 10, even though that is the value that comes by default. Set that to 10. And what we do here, we can add again at unit C, because we want to basically like move everything based on these numbers. So remember that Grasshopper, basically what it does, it gets data and then it maps according to the data matching that we are providing. It maps that function to that data. That is basically what is going on. So here, if we're for example, if we want to map a moving operation, we will visualize the data before. So the output of this element or this node here is what you see here. It's saying like, give me 10 values starting from 0 and with a certain step. So this is why it's giving me this, right? Numbers from 0 to 180. If I modify the step, it keeps the same amount, but basically it's just like changing those numbers, right? It's the step. We'll keep it to 20 again. And then if I connect all these numbers to unit C, what will happen? It will create 10 vectors changing that value of the C parameter, right? So that's what's going on, because I'm mapping this function to this data to get this. And now that I have 10 vectors, if I connect this to motion, and then if I connect this to geometry, it will repeat, basically it will move according to all these vectors. So again, it's receiving the curve, just one curve, one periodic curve, and then it's saying, okay, I need to match that data I need to map this function, matching that only element with the first vector, the second vector, the third vector. So this is why it's creating 10 repetitions. So let me delete that. Now that we have 10 repetitions, we can turn this off. That is pretty nice. So you see we're creating 10 repetitions. We can do the same thing with the second curve. Right? So now we have all these curves. So for now, we will keep this off. And we will, actually let's make this 30. Yeah, I think that's better. And because we're controlling the height with only one slider, you see that the repetition of the second curve also follows that. The same, basically, repetition, the same pattern of repetition. So now here, what we want to do is something, we want to flip every other curve, right? So what I mean by this, just let me bake these curves. Let me take them to the side here in Rhino. So what we want now is to perform the operation of like flipping, having something like this. Flipping all these curves. So yeah, it's a little bit more complicated than this, but basically we want this type of operation. So how do we do this? We can apply a code pattern again. So we can apply this code pattern. So we need to first create because we want to do this like every other curve that we repeated. Our code pattern or our mask will be true and false. Multiline data. So we want to now apply the code pattern here in our data here. So it will select, yeah, again, like every other curve, right? And we will use this to flip what we have. So there are ways to do this. Again, this is not optimized, but it's good that we're using like a lot of components. What we can do now is to, for example, apply a bounding box. A bounding box that, no, actually we want to have a oh, actually it is bounding box. So yes, bounding box. So what we're doing, we're getting a bounding box for each of the curves. Now we want to create basically like a flipping, a mirror operation. So we're just using this. Again, it might be inefficient, doesn't matter. We are using an area component. Double click, right, area, and you will see this M2 component or node. So we want to basically get this box and get the centroid, the geometric center of each of the boxes. That's the only operation that we're doing now. So let's just preview this curve. So we have that that's geometric center, and based on that center, we will go to vector, plane, plane origin, and get that use the centroid as the origin and as the base. So actually now I need to change the plane size. Let's put it back to 8. Yeah. So you see that now we are creating, based on that point, a plane XY, but at the center. because we will use that to actually generate another transformation. In this case, that transformation will be an Euclidean transformation. It's the mirroring, basically like reflecting this geometry. So if we go to transform Euclidean mirror, we will use that plane as our reference for the mirroring operation, and we will connect now the code list. So you see, now we're flipping that geometry. Pretty nice. And based on that flipping, now we need to actually perform another cooling operation. So now we have two sets. So now we want to, from this set of curves, we want to call every other curve. So we can just copy this call pattern and this first pattern. We can copy this again, and we can change and reverse the pattern here. We can say like false, true, because now the data that we are going to use is this one. We will connect the code list to this code pattern, and now the flip list to this other code pattern. Did I get it right? I think so. Yes. So yeah, we have this correct. So if you turn off all the curves before, and actually we're not turning this curve off, we have what we want. So let's just like decrease this, so you can see it like decrease the height. Let's go back to 20 again. What we are doing is from this set of cull curves, like every other curve, we are culling again. We are just like selecting this one, and this one, and from the flip curves, we're performing another culling operation. So we only get like half of the curves for each set, but we can see that now this curve is facing the opposite direction of this curve, the other one, and the other one. It works very nice. And we need to work now that we have this set of curves that works like pretty well. We want to perform one more operation here. We have now this set of curves, but what we want to do is to, at the same way that we want to select every other curve. So we want to deselect this. We want to get the curves that are in between. So we want to get this one, this one, this one, and so on and so forth. So we can use the same called pattern here, right? With the but with the inverted pattern. So remember here we just selected like every other copy, and now we want to do the same but with the opposite mask. So we want to, again, basically what we want to keep basically like the opposite pattern. So we will do false, true. I will turn this off. So now we have the data that we want. See? Pretty neat. And yeah, now it's clean. Pretty good. Let's play a little bit with the scaling, for example. So you want that type of pattern. All right. Actually, we could add another. It's fine. I'm not gonna Actually, what we need to do, now that I think about this, maybe the pattern should be the other way. This called pattern should be here, and this one should be here. No, let's just stick to this, actually. Yeah, let's not improvise now, because I don't want this video to be like too long. So now we need to perform two operations, because now we need to loft everything. But if we loft now, our data is not organized. Like if you do this in Rhino, of course, you can always like select this, then click here, click here, click here, like in order, and you will have a perfect continuous surface, because we're dealing with things that are generated parametrically. So we need to force the way that everything gets selected and organized. There are ways to do this. I'm going to keep it simple and consistent to the tools that we have used in this tutorial. So what I will do now is use two weave patterns. Remember the weave. So first I will organize this, and I will use this first weave pattern only with the pattern that is my pattern will be 0 and 1. It's just a panel 0, 1, multi-line data. This is the pattern. This is the first stream of data. This is the second stream of data. So I'm taking both curves, set of curves, and now this is a very organized and neat like set of data. So basically this will be element 0, 1, 2, 3, and 4 because of this operation. And we can do the same, we can perform the same weaving pattern, because now we want to create a list where basically we have this element 0, 1, 2, 3, 4, 5, and so on and so forth. So to do that, we can just like copy and apply the same weave pattern, where now the output of this node is stream 0, and the pattern of this node is stream 1. So if I turn off the visualization for that, we have one list that is organized in the way that we want. And we are now, I mean, what I want to do here is to include also the vase, like the vase circle, right? Because if we're going to 3D print, we might want to keep this. So to do that, we just need to add a simple merge operation where we will basically like merge two sets of data. So if I go to the beginning, we will input the first circle as the first element, then move all the way here and use the weave as the second one. How do we know that this is in the right order? So we can go to sets, list item, put this here, and add a slider, so like any numeric slider. We will delete these later. So first, what we want to do is to flatten, because right now, if I add a panel, our data looks like this. So basically it's like one list with the circle and another list with all the other curves. And this makes sense. So you see that it says that the element 0 is planar curve, periodic planar curve, periodic curve. Sorry, it's periodic curve. This is a periodic curve. Planar curve, periodic curve. So it makes sense that now our data, yeah, it's organized that way. But again, remember that every time that you have this dash connection, it means that you're getting more than one list of data. So what we want to do is to right click and flatten the output. And if we flatten the output, and if we go to the list item, we connect this slider here. And if we click on the list item but move now, you see that our element 0 is the circle, the element 1 is that periodic curve, next element is that planar curve, periodic, and so on and so forth. So now our data makes sense, and we can repeat and modify whatever we want. So I will delete this because we don't need it. We'll delete this because we don't need it. And we are done with the generation of the curves, right? So now that we are done with that, what we can do is to actually do what basically create the definition that it's in the actual book. So again, I didn't save this. You need to save this. So I will save this like lesson 02, whatever. And now from this merge result, we will do the following thing. We want to create now an X and C plane. An X and C plane. The origin, it doesn't matter. So we want to create this plane because now we want to intersect each of these curves, like each one of these curves. And to do that, we want to go to intersect physical, and we will do, is physical or mathematical? I always forget. It's plane and curve. Curve and plane. We want to go to intersect mathematical, and basically this component or node solves the intersection events for a curve and a plane. So we will connect our curves, we will connect this plane, and what we get, you see, if we go to the top view, are the intersections between that plane, that basically is exactly like horizontal following this red line, and those curves. So what we get, of course, are two intersections, because that plane is infinite. So we get two intersections. So what we want to do here, as the next step, as it shows, but it doesn't explain in the book, we want to deconstruct. We want to deconstruct these points, and we want to sort them, right? So we go to sort list. You can find that under sets, sort list here. And we will use as keys, the keys that we want to use are the X values, and we will basically sort the parameters C and P from curve plane intersection. So values A, and here we will change this to B and A. So let's call this B, and let's call this A, right? And now with this, right, because if we see like the data that we're getting, we need actually the values of A. So let's connect the panel. So these are the points, the filter points, according to the X value. They are sorted according to the X value. And we want to get, if we go to list item, actually let me go manually, like sets, list, list item. We want to map this function that will select only, like by default, the element 0, the first element of this list here. And with that, we will create the seam. If we go to, like, if we write seam, S-E-A-M, we want to create the, from our set of curves, actually let me do this because it's healthy. Sorry. Let's connect that curve container here and then curve. So we know that the first part of our definition ends up here, and then we can continue, right? So what we want to do is to get all of these curves and create a new seam for this curve. So we can actually turn this privatization off, And now we're ready to create our loft. And loft options as well. Options, curve. So you see, this is creating our surface. It's a continuous surface. So just let me bake it. Oh, it's creating polysurfaces. Yes, because we need to flatten this. We need to flatten the seam. So we need to flatten this value here, the seam value, so we are getting only one surface. So let me bake this. This now, it's we need to perform a couple of things. It's creating one polysurface. So we don't want a polysurface. So let me just remove this. It's creating, yeah, like 4 surfaces. Let's fix this. There's one thing that I need to fix as well. It's the rotation of a curve to align profile. So this doesn't look like the figure on the book yet, but we will fix it. So don't worry about that. We need to fix other things first. So it is a close. Let's manage these parameters here. Adjust. Set this to true. We can actually rebuild this. So let's rebuild this with, I don't know, like 48 points. So if we rebuild the surface for the loft, we eliminate the seam for the loft. So we have a surface now. And we can select the type, like normal, loose, straight, or uniform. Like uniform with uniform curvature. I think this is good. Let's play. So let me add a preview, custom preview. I'm not gonna change the material. I just want to see how the surface is going. So let's play a little bit with the scaling value. Yeah, so this looks more or less a little bit more or less like the so I think I'm missing something from let me check. Bueno, y ahora now sorry, now that I realize, yeah, I made a little bit of mistake here because this is not the right shape. So we need to perform a couple of modifications. Actually, I skipped that part, so sorry about that. What we need to do actually is, yeah, we need to have this profile rotated 45. So we need to do a couple of more things. So let's just use the same code patterns that we have here, and we will connect this code pattern here, this code pattern here. So if we previsualize this, we have these curves. And after that, what we want to do is to apply a rotation, right? Because we are going to rotate this set of curves here in degrees and 45 degrees, or whatever we want. So if we look at this, if I turn this off, we see that these are the curves that we need, because we need like this, basically this, we don't need this, like, let's say like bulge or whatever it is, like here, but we need it here. So now that we have here, we can apply a weave component. Sorry about that again. And our pattern will be 0 and 1. We will take 1 and 1. So basically we will take that curve and those curves in a new list of curves. Let me turn off the previsualization. And our second, like the pattern 1 from our weave will be that. That's the geometry that we need. So now, yeah, you see, you can control it. You can also parameterize that if you want. So let's just leave it at 45 for now. You can go back and play with the scale, right? This is the scale. That looks pretty good. Let's just turn off the previsualization for those curves. Have those curves there. So we have this geometry. So now to finish the exercise, let's create the isocurves. So now that we have our loft, we can do a simple thing. We can create another bounding box, round bounding box for the geometry. So we will enclose our geometry. Now we can deconstruct our box. Deconstruct box. And we can connect our box here. Just turn this off. Let me add a color. Yeah, let's make our geometry that color. So we have this, and now we deconstruct our box, and we can, for example, now apply a division. And we can divide we deconstruct the box, and now we deconstruct the domain. Because when you deconstruct the box, it gives you a domain, like something to something. So deconstruct domain. And we want to get the end of the domain divided by a number. So we can make this 1. So this will give you an actual number. And now what we want, for example, is to generate a range. This will be our steps, the number here, and the domain, it will be the domain by default 0 to 1. But if you want to write it, you can construct the domain saying that 0 to 1. No, 0 to 1, sorry, 0 to 1. So you have basically like all the intervals. And again, these are normalized values from 0 to 1 because that's what we need for our to extract the isocurves. So let's turn that off. And now what we need to do actually is to build our new set of points. So we will do construct point. We will add this to the x coordinate. So what we get is this. You'll be wondering why the x coordinate. I will explain in a second. Because what we want now is to extract the isocurves. So if we go to isocurve, oh sorry, it's in curve spline, isocurve. I don't know what I was looking at for at the surface. So isocurve, you connect this here, and you connect the loft. So what is happening here is this. You see that is creating like, it's making something down here because you need to reparameterize your surface. So if you press reparameterize, it will express the domain of the surface in terms of u and v, right, from 0 to 1. So if we do that, boom, we have all the curves in our surface. Again, that is pretty neat. I mean, it's I like it. So we have our surface with all of those isocurves. So you can play again with the parameters. Then I will show you how to create your own G code based on this, and also like play with the flow according to the height or separation of the curves. We will leave this tutorial up to here because I think this covers basically what's the exercise that some of you asked me in class. and also adds all the parameterization or the parametric work with the curves. Like going through, like, I don't know. I mean, it's a long definition, but I think it's good because we use a lot that calling pattern, like masking data and recombining data and doing a lot of things. So if you follow the video, I hope you can basically replicate the exercise that we did today. That I think is like pretty cool. So I'll see you next class. Watch the video here, and for the ones that are not part of the class and you're watching this video on YouTube, I appreciate any comment, and if you can subscribe to the channel to get more content. Thank you very much.